I'm the technical project lead for the EBI search team, which is a team within web production at EMBL-EBI. And I'm going to be talking this afternoon about EBI search. We're going to be doing a fairly high-level overview of what EBI search is and the EBI search web application. So a quick glance through the program. I'll talk about what EBI search is. I'll run through searching with the web application, including the page layout, how the data is arranged, the search syntax that is available, and then we'll take a quick break from the slides to run through the demonstration. And then we'll look at the EBI Search API, the programmatic way of accessing EBI search. And again, we'll run through searching, fetching specific entries, the cross-referencing functionality, and again, a demonstration. And finally, we'll finish up with some resources and useful links. So EBI Search is a Lucene-based full-text search portal. It allows you to search across many of the EMBL-EBI datasets. It's kept up to date. Data is indexed every 24 hours, and it provides a web application, so a web search front end, and also a RESTful API, which is used by the web application to provide results. So the web application actually uses the API as its own backend. In terms of statistics, we have nearly 4 billion entries, over 110 data sets, and we've had over 500 million requests from 970,000 unique hosts over the last 12 months or so. So we've been quite busy. In terms of searching with the web application, you can see here, this is the search front end. This is what you get when you go to the EBI search page on the EBI website. We have a search box in the top right corner, which allows you to do basic searches, field-specific searches, searches that are specific to individual data sets, and all of the above. Additionally, we've also got a query builder for creating complex queries if you need that kind of functionality. Looking at the search results page, the results are split into categories, and the layout that you see when you execute a search depends on the category that you're actually looking at. You can see here, we've got two categories on display in this screenshot, EMBL-EBI Web at the top and Literature further down. The EMBL-EBI Web results include snippets of matching text with hit highlighting enabled, while the literature results only include simple field data. So we've got the title of the document here, some metadata, the author, and a brief citation here for the result. EBI search data is arranged hierarchically. The content is arranged in domains. The domains represent a content area, and they are multi-level. So you can drill down into individual data sets. You see here, we've got a source filter at the top left of our screenshot. As you drill down into the results, we've clicked through to nucleotide sequences here. You get a breadcrumb trail appearing as you navigate through. And additionally, you'll notice that the facet options here on the left-hand side update by domain. So within nucleotide sequences, which is a mid-level domain, we just have organisms, which is a common facet across all of the nucleotide sequences. But if we drill down into the sequence domain, we get additionally creation date, country, and so on in the facets. The results page layout consists of a header with your search terms, the number of results that you're getting, and the breadcrumb trail into the data set that you're looking at. On the right-hand side here, we've got the results, while on the left, we've got filters and facets. So ways of refining your search results into more refined result sets so that you can find what you're looking for more easily. Finally, across the top, and again, this will vary by data set, we have tools available for saving your results in various formats, executing sequence similarity searches, and creating an RSS feed of your results. If we look at a single result layout here, at the top, we've got the result metadata next to the selection checkbox, consisting of an accession or a title link, details of the source domain, the data set that the result has come from, and a unique identifier associated with the item. The field data, as mentioned earlier, varies by domain. In this case, we've got a brief description of the item. Below that, we have cross-references. This is one of the most powerful features of the EBI search, and allows you to see other domains which reference this entry. And you can follow these cross-reference links to protein families, samples and ontologies, and so on, to see entries that reference this item in those domains. And finally, we've got raw data formats, which are available for some domains. You can see here we can download in EMBL format, EMBL SVA, and in FASTA format. The search syntax will probably be familiar to you if you've used something like SQL, or if you're familiar with Solr or Elasticsearch. If you're entering multiple search terms in your search box, they will be ANDed together by default. So it will return results which have all of those terms in them. You can also use AND or a NOT explicitly to format your query. You can quote terms for exact matches. You can use specific fields to search over by doing field name : and then your value. You use asterisks for wildcards, and if your search is complex enough that you need to group your clauses together, you can use brackets for doing that. Additionally, other Lucene search syntax is supported. There's plenty of documentation on the internet on Lucene search syntax. So I won't go into that in any detail, but you see here, you can do a search for ID. You can do a range search for ID star to star, which will find any entry in that data set which has a value in the ID field, which hopefully should be all of them. We'll just move to a quick demonstration of the EBI Search API, or the EBI Search web application, rather. I switch to my other window here. This is the main EBI search page. I'll just run through these tabs as well. We've got a help and documentation tab here, which provides some frequently asked questions and some links to things like the API documentation for the RESTful Web Services API, which we'll be covering in a few minutes, query syntax, a brief word about relevance, and so on. Additionally, we've got a statistics page which lists all of the available domains to search over. You can search through these. So if I just type Uniprot there, you will see that the Uniprot domain has appeared, and that belongs to the protein sequences category, which gives you some idea of where it sits in the hierarchy of domains. You see here we've got all of the categories arranged for each domain in turn. So if I do a quick search for human, you can see here what I was talking about earlier. We've got samples and ontology results. We've got bioactive molecule results with an image there. And if we drill down into nucleotide sequences, and the results appear. Facets are taking a little bit longer. The peril of doing live demonstrations. You see each result has its own link. These links don't actually stay within the EBI Search API. These links will take you to the home domain for those results. So if I click through for this one, for example, it actually takes us to the RNA Central page, where you can see far more information about that entry and its various properties. Just going to reload. Additionally, we've got cross-references here. If I click through there, we can see that this entry also has references in biosamples and in taxonomy. And the cross-references are bidirectional. So we could click through back into nucleotide sequences and see this entry referenced in 3,000 or so items in ENA in nucleotide sequences. If I click through to sequence on its own, I'm actually going to reset my search and start again. So drilling down into an actual domain, we can see here we've got our various formats for MH011443. You can download in EMBL format, which gives you the raw data for that particular entry. And in EMBL-SVA and FAST-A as well. You can select results and save them. In various formats, including just the ID list, CSV, JSON, or XML, or a list of the accessions. And you can create an RSS feed. If we just type a title and create RSS, you can see we've got an RSS feed here containing the results from my human search for TP53 rather, sorry. Clicking show more, you can see the protein sequences additionally to the other cross-references. And if I click through to Clustal, and that will take us through to the sequence similarity search for cluster omega sequence alignments. And you can see here the input sequences have been filled in with our accessions already for us. So let's just demonstrate the various facets. Our last modification date gives you a calendar for choosing your dates. Now I apply that, and we can see these are now limited to those 41 results from Kenya, which all fall within that modification date. So that was our brief demonstration of the EBI Search web application. We'll go back to the slides now. And I'm going to talk now about the EBI Search API. This allows programmatic access to the EBI search results, which means that you can integrate EBI search into your own projects if you want to, and you can automate searching. The URLs are RESTful, so they're built up in a structured fashion. We only have GET methods at the moment, but yes, they build up. And there's a full open API description at this web address, which gives full details of the various search options available to you. So a quick glance at what's available through the API. We have search, which, as you might expect, is searching against single or all available resources, all of the domains available to you. We have cross-reference searching for looking up cross-references between domains or individual entries in those domains. We have auto-complete for getting suggestions, top terms for retrieving popular terms from specific fields, a sequence analysis tool result search for searching across the results from external sequence analysis tools, more like this for finding entries which are like the entry that you're looking at, and raw data retrieval for getting raw data for a single entry or multiple entries. And again, as with the functionality in the front end, this is only available for certain domains. The REST style URL structure is all built from a base URL. We've got EBI search /web service /REST. And if you go directly to this URL on its own, that will return all the domains in XML format, much like the statistics page on the main website. If you want to look up specific domain details, you can append the domain to the end of that URL, and that will return the full details for that domain. There are a number of formats available. You use the format parameter to specify whether you want XML, JSON, CSV, or tab separated formats. For example, you can see here we're looking up the details for uniprops in JSON. Alternatively, you can use the accept header from an HTTP request for specifying the format that you want to receive your data in. For searching with the API, the URL structure is essentially the same as the previous one. You search over an individual domain using /domain and give it a query parameter. There are additional parameters that you can tag on the end as well. If you want specific fields to be returned, you can add fields and a comma separated list of the fields that you want to see. And you can also change the sort order of the results in ascending and descending order. And again, those are comma separated multiple fields. By default, the results will be ordered by relevance, which means essentially the closest match, quite likely the match with the most search terms, depending on which fields are being searched over and how the domain has been configured. But generally relevance will give you results with the most search terms from your query in them. We have a few additional format options when you're doing a search query. You can ask for RSS, ID list, accession list, and comma separated ID list and comma separated accession list as well. The list formats all return plain text rather than text/CSV or anything like that. It's all text plain. And obviously the RSS feed will be in XML. And yes, as I've mentioned, you use the fields parameter for specifying additional fields. To add facets to your search, you enable them using the facet count parameter. So you see here in our URL, we've got a query for TP53 in Uniprot, and we're asking for 5 facet items in all of the available facets for Uniprot. Just as an aside, in case you're not familiar, facets are essentially a way of grouping results by individual field values, such as keywords, country of origin, and so on. They provide a good count for seeing how many results you have that fall into those various buckets. And they're very useful for filtering down data, as you saw in the web application demonstration a few minutes ago. If you want to specify individual facet fields, if you don't want to see all of the facets, for example, you can use the facet fields parameter. If you want to filter by a facet value, you give a comma separated list of the facets that you want to apply. So in this URL, we'd be looking for items where the status field has reviewed in its value. And again, you comma separate multiple facets as they go through. Just as a note, you should use the facet value rather than the label. So for this particular facet that I brought up on screen, if you wanted to filter by taxonomy for Homo sapiens, you would actually set your facet to taxonomy :9606, which is the value for that facet rather than the label, which avoids any tricky issues with things like with quoting terms and so on. You can also return individual entries. We have an entry call within a domain which can return up to 100 entries, either by their ID value or their accession number. You specify the required fields and format using the fields and format value parameters, as you might expect, and you can fetch up to 100 at a time, as mentioned. In terms of cross-reference searches, you can find resources that are referenced by a domain. So for this particular domain search, we can see that it has references to Array Express repository, Atlas experiments, Atlas genes, and so on. You can find the resources referenced by an individual entry, which is what you see in the cross-references line for each result. So again, for this particular entry, which we've looked up by its ID, we see we've got one reference in Atlas genes, one in Atlas genes differential, 28 in biomodels, and so on down the list. And you can also look up the individual entries in a target domain for a single entry. So in this case, we've searched for P53 human in UniProt. That's UniProt is our domain. Our ID is P53 human. We're looking for cross-references in target domain of Europe PMC. And we get back a list of references from that. And if you go to Europe PMC, you can access those items directly from their ID values. More like this search enables you to find similar entries to an individual entry, either in the current domain or in a target domain. It's essentially an entry search, and you append the more like this path to the end of your URL. And it works by building up a query to look up common terms from the source entry. You can specify various tuning parameters. So MLT fields allows you to set the fields which can be used to generate the query and the lookup that you're going to do. MinTF sets the minimum term frequency for a term to be included in the query. So if the term doesn't occur that many times in your entry, then it will be ignored. Minimum doc frequency is the minimum number of entries in which a term must appear for it to be included in the query. And max query term is the maximum number of terms which you can include in a query when you're doing a lookup. And that's actually limited to 25 to keep search time to a reasonable level. Following on from more like this, we have auto-completion, which allows you to look up suggestions based on incoming terms. You see this a lot on sites like Google and so on, and it's also available in the web front end for EBI Search. You supply one word at a time with a minimum of 3 letters in that word, and results may be formatted, so highlighted or plain. And we see here we've asked for a formatted result for TP5, and one of the suggestions is TP53B_mouse, and the formatted result has a span around the TP5 there. Top terms enables you to find the most popular terms in a field within a domain. So if you wanted to find the most popular terms within a title or a description, you would use top terms to do that. One caveat for this is that top terms must be enabled on the field you're searching over. So if it isn't, you won't get any results back. When you execute this, you will quite likely see lots of short results if you're searching over a field which has got lots of English text in it, like a description or an article body. You'll see lots of ofs and ands and these and other common words in English. So you can actually tune the results by excluding those from the list of words that are allowed in the result set. You can either specify single words using the excludes parameter, or you can use a predefined set of words such as Lucene stop words, which is it's the default Lucene stop word set for English, which includes of, and, the, a, an, and so on. Lots of common words in the English language. So we'll pause the presentation again and go to a quick demo. And if I just switch to my browser session again, we'll start off with the base. Whoops, I missed a word. Start off with the base domain information. And this is coming through in JSON, and you can see here we've got our subdomains, we've got our hierarchy structure. Essentially, we've got all EBI, which is our top level domain and contains all of the other domains within EBI Search. And our first subdomain is genomes, for genomes and metagenome data. And within that, we've got subdomains, final lowest level leaf domains of DGVA, EGA, and so on. And if we go to the bottom, you'll see genome variation is the lowest level and has EVA studies in it. If I switch the format to XML, you see the same here, only in XML format. If we actually go through and look at an individual domain, I'm going to look at RNA Central. You can see we've got the index information, we've got the number of entries in the domain, so 30 million in RNA Central, some metadata about when it was last updated, a description, and the name. The domain ID matches what we saw in the statistics page earlier, and that's what you actually put in the URL up here. And then we have the field information. So you can see here the cross-reference fields are all capitalized. They're fully capitalized. And if we drill down a bit further, you see our regular fields and the various configuration options which have been set for the individual fields. So whether it's searchable, whether it's retrievable. Searchable obviously means it can be searched over. Retrievable means that it can be retrieved and displayed in your result set. Whether there are facets available, whether it's enabled for top terms, which is true false value, and so on. If I do a quick query from the base domain, you can see here we just get a hierarchical breakdown of results within the various subdomains within the EBI search. So at the top level, for human, we've got 68 million or 68.5 million results. And then we've got genomes, and within that, we've got 43 results within DGVA, 5,000 within EGA, and so on. If we actually go to our individual domain, if we search through RNA Central for human, this is the basic result set that you get back. You see we've got some basic entry metadata here. We've got the source value and we've got the unique ID. If I just change that to Uniprot, which has accessions as well, you see we get accessions, IDs, and the source of Uniprot. That is probably not very useful unless you actually know off the top of your head exactly what these IDs refer to. And I know there are some people out there who do. But I'm just going to add some fields to that query. Oops. So we can see some more information on the results that we're getting back. And you see here we've got common name human and description because we've done a search over human. All of our description values also include the word human, certainly in these top 15 results. You can add a size parameter to cut down to a single result, and I will enable facets so we can see all of the facets available on RNA Central for the results for human. And you see here we've got, in addition to our entries, we've got a facets block with our various facets in them. Has genomic coordinates, has secondary structure, and so on. When you come to actually filter by facets, you use the ID value rather than the label. So you'd put has genomic coordinates rather than genomic mapping in your facet field list. And we'll just cut down our facet fields to has genomic coordinates, taxonomy, and the SORNA type facet. So you see here we've got our taxonomy labels and so on. We've got has genomic coordinates, and down here in SORNA type, we've got a hierarchical facet. So hierarchical facets allow you to actually have multi-level faceting on your result. You'll see we have 3 levels currently on display. If you wanted to actually drill down into those facets, you do that using the facet fields value, and you slash separate your facet values. So if I go into ncRNA, which is the top level here, you will see that our facet value, the top level, is now lncRNA, which was the first nested within our ncRNA hierarchy shown previously. And if I then go into rRNA, you see here we've got rRNA, we've got systolic rRNA, and then in the next level down we've got systolic LSU. So we're at 3 levels of drilling down into those values. So if I then copy this into my URL, and close up my facets again, you can see we've actually drilled down and made the facet values more specific for this systolic rRNA values there. To apply a facet, as we talked about in the slides, we add facets equals, and if we just has genomic coordinates. False. You'll note that this is case sensitive. You can see that our results were actually reduced from 570,000 to 96,000, which is the number which have genomic coordinates available. I'll just talk briefly about hit highlighting as well. You enable hit highlighting using the HL fields parameter. Whoops. Wait for the zoom control to go away. You see here, this is our human query. We've got a couple of fields specified, and we've asked for common name and description to be highlighted in our results. And for this top entry, you see we've got highlights on common name and a highlight on the description value with human emphasized with EM tags, which are the default highlighting tags. You can actually change that. You can set HL pre-tag equals, I'll just use HL, and HL post tag equals closing HL, and you'll see here that has now changed. And I'm going to end the demonstration there and go to the Q&A. Thank you for listening so far. If I go back to my presentation, got our useful resources slide, which I'll leave up as we go through the Q&A. Links for the documentation and the API documentation, and this is the link to our user support form. So yeah, thank you for listening.